So how do these data illustrate the law of multiple proportions? Now, John Dalton's theory was when two elements, and that's what we have here, we have sulfur and fluorine, combine to form a series of compounds. So let's call this compound A, compound B, compound C, that the ratios of one of those elements, in this case fluorine, when the other one is constant, like 1 gram, the element of, in this case, fluorine, can always be reduced to whole numbers, so a simple whole number. So we're going to illustrate that using this data. Let's go. I'm going to, let's see here, let's just choose a different color. So they're just going, let's go like there to there. Compound A to B, we're going to compare the masses of fluorine, one of the elements. All right, so 1.188 grams, this is A to B, to 2.375. You don't need a calculator because it already tells you that these are going to be multiples. But you can pull out a calculator. That's going to be 1 to 2. All right, whole numbers. A to B ratio is 1 to 2. So we can do, let's go to A to C now. So A to C, the ratio, let's check it out, is going to be 1.18. Let me write that. That's supposed to be a decimal, 1.188 grams to 3.563 grams. You can pull out your calculator, and that's going to be 1 to 3. I'm sure it is. All right, so another simple whole number ratios between A and C. And so therefore, you can say A to B is, we just did A to B, sorry. B to C we haven't done, right? All right. So B to C is going to be 2 to 3. Again, whole number ratios. Right, you could have flipped all these around and got 2 to 1, 3 to 1, and 3 to 2. But the point is, because all of these, for fluorine at least, in all three compounds are all multiples of whole numbers, this is why it illustrates the law of multiple proportions.